Topic number 5 is maximum and minima of functions of one variable. Okay. So, now the maxima and minima of f are called extreme values of f. So, now let us define what is absolute maximum or global maximum and absolute minimum or global minimum. So, if this condition is satisfied for all x in the domain D, then we say that the function is absolute maximum. That is, f of c is greater than or equal to f of x, and for absolute minimum f of c is less than or equal to f of x. And now we are supposed to find the critical number, define the critical number. A critical number of a function f is a number in the domain of f such that either f dash of c should be equivalent to 0 or f dash of c does not exist. Okay, these are the two conditions for finding the critical number. Then for increasing decreasing function, I have given the definitions here. F dash of x greater than 0 in an interval implies that f is increasing in that interval, and similar way f dash of x less than 0 in the interval implies that f is decreasing in that interval. Next comes the concavity test. So, concavity test is if f double dash is of c is greater than 0, then we say that f is concave upward, and if f double dash of c is less than 0, then we say that it is concave downward at that point. Next is the point of inflection. A point P on a curve y is equal to f of x is called the inflection point if f is continuous there and the curve changes from concave upward to concave downward or from downward to upward, either way. Okay, so that point we call it as a point of inflection or inflection point. So, here is a first derivative test, and next is the definition of second derivative test. First derivative test we will be using it for finding the increasing, whether the function is increasing or decreasing, or whether the local maximum or local minimum exists. And the second derivative test is for finding the concavity. Okay. So, these are the basic tests we have, and for closed interval method is used for finding the absolute maximum and absolute minimum. So, let us start with the problem here. See the problem. Find the absolute maximum and absolute minimum value for function f of x is equal to 3x power 4 minus 4x cube minus 12x square plus 1 in the closed interval minus 2 comma 3. Okay. So, if you want to solve all these things, basically we need to find the critical points. So, let us first find the critical point for this function. Okay. So, here f of x is equal to 3x to the power 4 minus 4x cube minus 12x square plus 1. So, when you differentiate this with respect to x, differentiate with respect to x. So, you will be getting f dash of x is equal to, here it is 12x power 3 minus 12x square minus 24x. So, here everything is a multiple of 12. So, let us take 12x common. So, if you take 12x common, the first term will be x square and the second term will be x and the third term will be 2. So, in order to find the critical point, so let us find the critical point. Find the critical point. So, f dash of x will be equated to 0. So, f dash of x is nothing but 12x times of x square minus x minus 2 equal to 0. So, this implies x is equal to 0 and x square minus x minus 2 equal to 0. So, now see here, product should be minus 2, addition should be minus 1. So, we are just finding the factors. So, this is 2 times 1. So, minus 2 and plus 1 will give you minus 1, and here the product will be minus 2. So, you can factorize this as x minus 2 into x plus 1 equal to 0. Therefore, the value for x is nothing but 2 and minus 1. Therefore, critical numbers are x is equal to 0, 2 and minus 1. So, according to the definition of closed interval method, we need to find the value of f of x at all these critical numbers as well as at the end points of the given interval. The end points are nothing but minus 2 comma 3. Out of all these, totally here you have 3 critical numbers and here you have 2 end points are there. Therefore, totally you will be getting 5 values. So, out of these 5 values, you have to choose which one is the maximum value. And similar way, and the minimum value will give you the absolute minimum value for f of x. So, now let us start with x is equal to 0. So, let us substitute x is equal to 0. So, what will be the function value? F of 0 will be equivalent to, so the function is nothing but 3x power 4. Let me write that also. F of x is nothing but 3x power 4 minus 4x power 3 minus 12x square plus 1. This is the given function. So, at the point x is equal to 0, this will give you the value as 1. Okay. So, the value of f of 0 is nothing but 1. Similarly, at x is equal to the next critical point 2. So, at x is equal to 2, this is nothing but f of 2 will be equivalent to 3 times 2 power 4 minus 4 times 2 power 3 minus 12 times 2 square plus 1. So, this is nothing but 3 times 2 power 4, then here 8 times 24 minus 12 times 4 plus 1. So, this is equivalent to 48, 32, 48 plus 1. So, this is minus 32 plus 1 will give you minus 31. Similar way, at x is equal to, the next critical number is minus 1. At x is equal to minus 1 we are going to find. So, this is f of minus 1 is 3 times minus 1 the whole power 4 is plus 1, minus into minus will become plus 4, and for the next term it is minus 12 plus 12. So, this is 7 minus 12 plus 1. So, this is going to give you the value as minus 4. And similar way, at end points also we are going to find the value of f of x. So, end points are nothing but minus 2 and plus 3. So, we need to find what is f of minus 2. So, f of minus 2 is nothing but 3 times minus 2 the whole power 4 minus 4 times of minus 2 the whole power 3 minus 12 times minus 2 the whole square plus 1. So, this is nothing but 3 times 16 minus into minus is plus 4 times 8 minus 12 times 4 plus 1. So, this is 48 plus 32 minus 48 plus 1, which gives the value as 33. Okay. Same way, at the other end point, that is 3. So, at x is equal to 3, the value is nothing but 3 times 3 to the power 4 minus 4 times 3 to the power 3 minus 12 times 3 the whole square plus 1. So, this is equivalent to 3 times 81 minus 4 times 27 minus 12 times 9 plus 1. Okay. So, when you simplify, this is going to give you the value as 28. Okay. So, out of all these 5 values, the maximum value is 33. So, over here. So, it occurs for x is equal to minus 2, and the minimum value occurs at this. Okay. So, this is going to be the minimum. Therefore, the absolute maximum value is f of minus 2 is equal to 33, and the absolute minimum value is f of 2 plus 2, which is equal to minus 31. Okay. Next, we will move on to the next problem. So, given function f of x is equal to 2x cube plus 3x square minus 36x. So, we are going to find the intervals on which it is increasing and decreasing, and second subdivision we are going to find the local maximum and local minimum, and thirdly we are going to find the intervals of concavity and the point of inflection. All these things in the same problem. Okay. So, we are going to find the intervals on first one is we are going to find the intervals in which the function is increasing and decreasing. So, for that we need to find the critical numbers. Critical numbers we can find with the help of f dash of x equated to 0. So, let us find the differentiation with respect to x. So, what is f dash of x? F of x is this term. So, when you differentiate this, you will be getting it as 6x square plus 6x minus 36. Okay. So, we can take 6 common. So, this will be x square plus x minus 6. So, in order to find the critical numbers, we need to equate f dash of x to 0. So, this is equivalent to 6 times of x square plus x minus 6 is equivalent to 0. So, here product is minus 6 and addition is 1. Therefore, this is 3 times 2, which is going to give you the value as minus 6, and 3 times minus 2 will give you the product as minus 6 and it will be plus 1. So, this is 6 times of x plus 3 into x minus 2 equal to 0. So, you can get the value of x as minus 3 and x is equal to 2. Okay. So, these are the two values you are going to get. Okay. These are the critical numbers. Okay. These are the critical numbers. So based on this critical number, we are just going to break the number line. Okay. So here it is minus infinity to plus infinity. So origin, somewhere over here 2 and somewhere over here it is minus 3. Okay. So we are just going to break this into 3 different intervals. So let us form a table here. So let us have this as, so let us the first column be interval, then the second column be f dash of x, then the sign of the function, then the conclusion based on this f of x. So here we have divided the interval into 3 different things, that is x less than minus 3 and minus 3 less than x less than 2 and x greater than 2. Okay. So what is the value of f dash of x? F dash of x is nothing but 6 times, already we have done here, the 6 times x plus 3 into x minus 2. So if you want, we will write here 6 times x plus 3 into x minus 2 is here. Okay. So x less than minus 3. For example, let us take some value, say minus 4. So when you substitute this in f dash of x, so minus 4 plus 3 will give you minus 1, and here minus 4 and minus 2 will give you minus 6. So this is going to give you a positive value. So the value is nothing but 36. If you substitute x is equal to minus 4, it is going to give you the value as plus 36. Okay. So this will be plus 36. So this is positive. So positive implies the function is increasing in the interval. Similar way, we are going to consider the next interval minus 3 to 2. Let us take the value of x as 0 in this case. When you take it as 0, it will be 6 times 3 and minus 2. So 18 into 2, it is minus 36. So this is going to give you the value as minus 36, which is going to be negative. Function is going to decrease in the interval minus 3 to 2. Similarly, for x greater than 2, let us take the value for x as say 3. Okay, if you fix x is equal to 3, when you substitute, this will be 6 times 3 plus 3 again 6 and 3 minus 2 is 1. So 6 times 6, so this is going to be plus 36. Okay. So this is again positive. So obviously you are going to get an increasing function within the interval. Okay. So we have concluded that within this interval the function is going to increase. Within the interval minus 3 to 2, the function is going to decrease, and for x greater than 2, it is going to increase again. Okay. Let us move on to the second subdivision. So what is the second subdivision? We are going to find the local maximum and local minimum. Local maximum and local minimum. Again, we can conclude with the help of the previous table itself. Already we have broken the interval with the help of critical numbers. We have identified where the function is going to increase and where the function is going to decrease. So now, if we want to find the local maximum and local minimum, we can see the sign changes. Okay. So here we can see that f of x changes sign from increasing to decreasing at the point x is equal to minus 3. So at x is equal to minus 3. Therefore, since the function increases, sign changes from increasing to decreasing, since the curve changes from increasing to decreasing at x is equal to minus 3, we say that local maximum exists. So local maximum exists at x is equal to minus 3. Therefore, the local maximum value is f of minus 3 is equal to, we are just substituting in the original function. So original function is something like 2x cube plus 3x square. So 2 times of minus 3 the whole cube plus 3 times of minus 3 the whole square minus 36 into minus 3. So this is going to give you the value as, this will be minus 54 and this term is plus 27 and this is minus and minus is plus 108. So this is going to give you the value as 81. Therefore, the value of f of minus 3, that is local maximum value, is 81. Similarly, f of x changes sign from the table. Okay, f of x changes sign from negative to positive, that is decreasing to increase at x is equal to 2. Therefore, the local minimum occurs at x is equal to 2. Therefore, the local minimum value is given by f of 2, that is equivalent to 2 times 2 power 3 plus 3 times 2 square minus 36 times 2. So this is equivalent to 16 plus 12 minus 72. So this is going to give you the value as minus 44. Therefore, the local minimum value is f of 2 is equal to minus 44. Now we will move on to the third subdivision. So what is our third subdivision? We need to find the intervals of concavity and the inflection point, that is point of inflection. So if you want to find the intervals of concavity, we have to go for the second derivative test, right? So what is that second derivative test implies? So let us start here. For doing the third subdivision, we need the second derivative test. So we need to find the second derivative. In order to find the critical numbers, we need to equate the second derivative to 0. So that is f double dash of x is equal to 0. So what is f double dash of x? Already we have found f dash of x. That f dash of x is nothing but, what is your f dash of x? It is 6 times x square plus x minus 6. So it is 6 times x square plus x minus 6. So when you differentiate this again with respect to x, this is going to give you 6 times 12x plus 1. So that is nothing but, when you equate this to 0, f double dash of x equated to 0 will give you 12x plus 1 equal to 0. Sorry, that is 6 times, this is 2x. Wait, okay, so this is 2x. So 2x is equal to minus 1 and x is equal to minus 1 by 2. So the value of x is nothing but minus 1 by 2. So we are going to divide the number line with the help of this critical number. Therefore, you will be getting the table as, and the interval will be, so here comes the interval, next is the f dash of x, then the sign, then the conclusion, that is concavity upward or downward. Okay. So this is what we are going to write. Now the interval is minus infinity to minus half and minus half to plus infinity. We have divided the number line into two different intervals. So for x less than minus half, let us take some value, say minus 1. So if we choose minus 1 within this interval, so what will happen when you substitute in f double dash of, this is the thing but f double dash of x. When you substitute this in f double dash of x, so this will be 6 times minus 2 plus 1. So this will be negative. So you are going to get a negative sign. So it means that it is concave downward. So it implies it is concave downward. Similarly, for minus half to infinity, let us take the value as x is equal to plus 1. So if you take x is equal to plus 1, so this will be 6 times 1, 2 times 1 plus 1. So this is going to give you a positive value. So here the sign is nothing but positive. So it means that it is concave upward. Okay. So this is how we are supposed to use the concavity test, that is second derivative test, for finding whether it is concave downward or concave upward. Now we are supposed to find the point of inflection. So whenever there is a change in concave upward to concave downward, or either from concave downward to concave upward, there will be a point of inflection. So we can observe that at x is equal to minus half, there is a change from downward to upward. Therefore, the point of inflection occurs at x is equal to minus half. Point of inflection occurs at x is equal to minus half. Therefore, we need to find the exact point. Therefore, for x is equal to minus half, we will substitute this in the original function f of x for finding the value of y. So, f of x is nothing but 2x cube. So, this is 2 times x cube, x is nothing but minus 1 the whole cube, then plus 3x square plus 3 minus 1 by 2 the whole square minus 36x, minus 36 into minus half. So, let me write here. So, f of x is nothing but minus 2 by 8, then plus 3 by 4 plus 18. Let me cancel out that and let me write it as 18. Okay, once again. Okay, so let me write this as 18 here. So this is equivalent to minus 1 by 4 plus 3 by 4 plus 8. So this is plus 2 divided by 4 plus 8. So this is equivalent to 1 by 2 plus 8. So this is 17 divided by 2. Therefore, the point of inflection is minus 1 by 2 comma 17 by 2. Okay. So, in the same problem you have learnt all the three things, that is increasing and decreasing, local maxima and minima, and then concavity. Okay. So, all the three things, and along with that you have learnt the point of inflection also. Okay. So, with this we will stop. Thank you.